Hello, good morning. Good morning to everybody. I am D. Mitra. I am Group Head of the Marine and Atmosphere Science Department of Indian Institute of Remote Sensing. Today, we are going to discuss about the remote sensing and GIS for the coastal and the ocean sciences. So, I will try to make things brief and to the point because time is not very much and the subject is very huge. So, in this 1 hour time, I'll try to give maximum what is possible, what IRS has done, and what are the possible areas where remote sensing and GIS can be used for the coastal and the ocean sciences. First, let us see the very fundamental definition of the coastal zone, which can be defined as a transitional area between the land and the sea. So it is a band rather than a line. So when we talk about the line, we used to talk about the land and the water boundary. There is a sole line. But when we talk about the coastal zone, it will be a basically area. So in a GIS, coastal zone will come as a polygon, but land and water boundary or the sole line will come as a arc. So it is a band rather than a line. The width of the band varies from place to place and is determined by the interaction of the marine and the terrestrial processes. So the width of the coastal zone is not fixed everywhere. It depends on how your terrestrial processes and the marine processes are interacting with each other. If the marine process is very strong, it will push the coastal zone far deep inside the land and vice versa. This zone is occupying less than 18% of the total Earth land surface. So this zone is very narrow, but you can see that this 18% of the total Earth surface, it accommodates more than 60% of the world population. That means the density of the population is tremendously high in the coastal zone, and definitely there will be then huge pressure on the coastal resources. And also it has been seen that 40% of the around 1 million kilometer long coastline of the world which is accessible, so that means a human being can reach there, and temperate enough to be habitable, so we can stay. So rest of the 60%, neither it is habitable nor few places is not at all accessible. So in a nutshell, if you see why coastal zone is important, basically, I will try to show you some bullets, but this is not the exhaustive list. There may be so many bullets under this umbrella. It is around 18% of the surface of the globe. 60% of the world population are living within this 18% of the surface of globe, as I have mentioned already. Two-thirds of the major cities in the world are lying in the coastal zone. In India, if you see, except Delhi, all the three mega cities like Kolkata, Chennai, Mumbai, they are lying in the coastal zone. Except this, also there are so many other big cities like Trivandrum, like Vizag. They are also lying in the coastal zone. Definitely, as area is small and population is too much, then population density is 6 times higher than the non-coastal areas. 90% of the world fish catch are coming from the coastal water. It is mainly because the coastal water is very productive. Productive in the sense there are a lot of phytoplanktons, which are microscopic plants, which are basically food for the fishes. And why it is so? Because coastal areas are the areas where the rivers from the land they are coming and meeting in the ocean, particularly in the form of estuaries, or they may form the delta. So while coming from the land, they bring a lot of nutrients en route, and they are dumping those nutrients also along with the sediments and other terraneous objects in the coastal water. So the fishes prefer to be in the coastal water to get the fishes. So it has been seen that 90% of the world fish catch, they are coming from the coastal water. That means coastal water is highly productive. And basically I will show you afterwards that how the remote sensing can be used to understand the where there are the potential zone for the fishes. And as we have told that coastal zone is a area part of the land and a part of the ocean. So 18% of the surface of the globe, so 8% of the ocean surface is coming under the coastal zone. 75 to 80% of the global sink of the suspended river load are happening in the coastal zone. So all the sediments which the rivers are bringing from their source to the where they are meeting in the ocean, particularly those sediments they are dumping in the coastal water. So that is around 75 to 80%. 90% of the global sedimentary mineralization are happening in the coastal water. For the geologist, particularly, they will understand that how the mineralization forms, and there are various processes of mineralization like igneous process, sedimentary process, metamorphic process, and out of all the global sedimentary processes, around 90% is happening in the coastal zone. So coast is a very vital importance of the humanity, because the human civilization started at the coast. So from the very beginning, the population of the coastal zone is higher than the land area. So all the big expeditioners, particularly the Columbus, the Vasco da Gama, they started discovering different parts of the world, and they first used to travel by ship, and they landed in some coastal area, and the civilization started from the coast. All the civilization like Mohenjo-daro, Harappa, there are evidences that they were part of the coast earlier, and it is a essential and the fragile element of the global ecosystem. It is very important, very complex ecosystem, and also very fragile. That means if you disturb one part of the coastal ecosystem, it is going to disturb the other part of the coastal ecosystem. Like if we cut the mangrove, it has a very long effect on the other coastal ecosystem, and it is a zone of very rapid transition, gradient, and the variation. There are a lot of variation in the coastal zone. It's a highly dynamic, because you may be aware that there is a high tide, there is a low tide, continuous, there is something or other is happening, erosion is happening, deposition is happening. It's a very dynamic areas. So that is why it is very difficult to put the boundaries around. So boundaries used to be like land water boundary used to be very fuzzy, very difficult. It's not any constant boundaries like lithological boundaries and other thing which you talk in the geology is concerned. But it's a very dynamic area, and also subject to multiple use. Lots of people are using coastal zone for their own benefit. Lots of activities are happening in the coastal zone. In the next slide, you will be able to see what are the various kinds of activities which are happening in the coastal zone. You can see the schematic diagram. Lot of activity, industries coming up, lot of quarrying activity, sand extraction, oil extraction in the coastal water, agriculture activity, extensive agriculture, forestry activity, new urban areas are coming up, lots of touristic activity, military activities, naval activities, food protection, irrigational activities, lots of artificial structures coming up to control the erosion, land reclamation, dumping of the waste. So in number of activities are happening. So much of activities in the coast, and all the activities have somewhere or other is going to impact the coastal zone. So we need to understand that these activities may be important, but how to minimize the impact of the coastal zone, that is the basic crux of the we call the coastal zone management. How to manage the coastal resources, because ports has to come up for national interest, naval activities has to be there for national interest. So we cannot tell that we should not do all those activities in the coastal zone, but we need to understand how the effect will be minimized, where we supposed to do those activities, like what will be the environment impact assessment. All these studies need to be assessed, and remote sensing is one of the important players in the scientific community, which can give you very detailed idea, and also can address the temporal domain of the coastal zone. So now if we want to see what are the various kinds of activities in the coastal zone, if you try to summarize, there are extensive resource or intensive agriculture activity, like the fruit, vegetables are coming up, lots of aquaculture activities, artificial fishing, lots of fisheries activity in the coast, exploitation of the minerals in the form of the offshore oil exploration, onshore oil exploration, sand mining, salt industries, other minerals your heavy minerals extraction, deep sea mining, manganese nodules exploration onshore and offshore. Lots of industries are coming up. There may be the shipping industries, shipping, building, maintenance, braking, oil refineries, fish and the mineral resources. Lots of tourism activities, as we are mentioning, where there are good beaches, swimming activities, sailing, ecotourism concept is coming up nowadays. Lots of infrastructure is coming up in the coast. Lots of new harbor sports are coming up. Lot of pipeline, canals, road, good transport activity, navigation and the communication. Lots of dike reinforcement of the coast, like breakwater, dikes, revetments. Lot of things are coming up, groins in the coast to protect the coastal area. And above all, there are a lot of border activity, defense, and the naval activities, particularly the areas which are having the international borders, like Gulf of Kutch, Bangladesh border, Sri Lankan border. Lots of activities by Indian Navy that are happening in the coastal area. So the major highlights of the coastal zone is a high population density and high degree of urbanization. Lots of new cities, lots of hotels are coming up in the coastal area. Very fragile and complex ecosystem. High density of economic activities, infrastructure. We have seen the earlier schematic diagram. And also definitely there will be a lot of competition for the resources and conflicts. When there are a lot of activities, obviously there will be competition. Over exploitation, that is very sad part. Nowadays almost all the coastal resources of India and the other parts of all developing countries, there is over exploitation of the resources. Pollution, coastal zone is highly polluted by lots of anthropogenic activities. We'll see what are the various ways that we are polluting the coastal environment. degradation of the natural environment by again anthropogenic activities, and also definitely there are natural causes for this: loss of biodiversity and natural habitats, increased erosion and loss of protection against the sea or the ocean flood. Sea level is rising because of the global warming and the thermal expansion of the sea water, so it increases erosion in the coastal area. We are losing land, and definitely because of all this, there is a from the societal point of view, there is a rise in the social inequality in the poverty in the coastal zone. So basically, to address this, we now we're talking about the coastal zone management. Basically, it basically involves all the planning and the organization of the development processes and control the activities in the coastal area, aims at the sustainable use of the natural resources of the coastal zone. So this is very important word nowadays. We are talking more everywhere is the sustainable use. That means you should not destroy any natural resources. So you should save the natural resources. You use it, but at the same time, like you are using, you have cut mangrove somewhere. Mangrove have been degraded. Definitely, you should look for the afforestation of the mangrove. So that is what that you should keep the resources which can be used for your next generation to come. That's we call basically the sustainable use. Sustainable use of the natural resources of the coastal zone is very very important, and that is the basically the crux of the coastal zone management, which we are now looking for. And basically, the for coastal zone management, we need lot of information, because we have seen the coastal zone, lot of disciplines are involved in the coastal zone, lot of data supposed to come from the coastal zone. So the information required for the management of a coastal zone is very diverse, because there is a series of aspects that play part in any activity of the coastal zone. So there, when we talk about the coastal zone management information system, like if we are talking about the coastal zone management database, if we want to create a database, it has to be open system, able to combine different kinds of data that can be extended to the several levels of details. And basically, when we talk about the coastal zone management organization, it is very clear that there is no coastal zone manager as such. Nobody can tell that I am a coastal zone manager, because coastal zone management activity is mainly the responsibility of the different government organization. And coastal zone management activity involves several disciplines. In any coastal zone, so many disciplines involved in a particular area. So nobody, it is not possible for any single person to know everything. Like you can see, the only the few bullets. There are so many other bullets may come. You can add this, like hydrology, soil water conservation, environmental expert will talk about the coastal environment. The water part hydrologist will explain the forester activity. They will talk about the coastal forestry, the mangrove study, agroeconomy, physical planning, sociology, anthropology. There is also economical activities. Also, there you need to take help from the geologist, the geomorphologist. So there is a n number of players who give their own expertise to show that your coastal management activities can be successful. So that is why I used to talk that there should be total link up of the various government organization, and they should provide their own data set for basically a useful coastal management planning. When you talk about our Indian coast, now I am coming to our Indian coast. Those are all basically the introduction part. We have seen that we have around 7,500 kilometer long coastline, which can be divided majority by east coast and the west coast. East coast is characterized by large fan-shaped delta, mangrove, like world largest delta like Sundarban, Sundarban mangrove. So one third is in India, two third is in Bangladesh. Bitarkanika, Pichavaram, the mangrove patches. Saline lakes we have in Chilka, in Pulicat, and also we have Gulf of Mannar, where near the Sri Lankan coast. Also, we have in the west coast, there is a very narrow coastal strip. There is a good number of estuaries in the western coast, like Narmada, Mai, Sabarmati, Dhadar, Tapi. So they are the estuaries. We have creeks, backwaters, sandy beaches, and there are the gulfs, particularly the Gulf of Kutch and Gulf of Khambat. I have told the estuaries Narmada, Tapi, Mahi, Sabarmati. We have also coral reefs limited, and also mangroves. But the east coast is mainly dominated by a lot of deltas, which are not there in the western coast, like Sundarban Delta, like Krishna Godavari Delta, Delta in the Mahanadi Delta, and also we have an important Andaman and Nicobar Island, which is mainly characterized by dense forest, mangroves, meanderic saline creeks, and also coral reefs, mainly the Bay Area reefs. Lakshadweep Island, mainly corals in the form of atolls, and also we have 14 marine and the coastal protected areas. So this is what basically Indian coast characterized of. But what are the major issues in the coastal zone management when Indian coast is concerned? Particularly when we talk about the major issues of the coast, basically, what I feel that the first and the foremost is the population pressure. Because if population pressure it would have been not there in the coastal area, then definitely we should not bother so much about the coastal exploitation of the over exploitation of the coastal resources. Because when the population is high, definitely exploitation will be more. So first important issue which you need to address when coastal management is concerned is the population pressure. Now, definitely the mangrove and the coral reef ecosystem is coming into the picture, who are degrading very fast. Because coral reefs are also they are degrading because of the increase of the temperature of the ocean water. We call the coral bleaching. Also, mangroves are being cut for the various reasons, and also satellite data can give you a very nice picture of the how the mangroves is being cut for various activities, which I will show you in the next few slides. In the coastal water, there are a lot of industrial effluents are coming up, solid waste disposal from different industries, municipal sewage, wastewater disposal, the agriculture sewage. They are all polluted water they're dumping in the coastal water. So coastal water is getting polluted, ecology is degraded. Lot of natural disasters, basically we don't have much role because the disasters will be there, only we can prepare ourselves to combat the disasters. Like there in the eastern coast is battered with cyclone. Now of late the tsunamis, storm surge, erosion, all those things are there in the eastern coast. And also western coast nowadays, now cyclones are coming, and so many other disasters also in the western coast. Impact of the aquaculture in the coastal area. Coastal erosion, we are losing very precious coastal land because of the erosional activities. And also definitely there are a lot of impact of the establishment of the port, because it has been seen when Paradip port came in the Odisha, and there are a lot of land getting eroded in the upstream side, in the downstream side of the Paradip port, because all the because disturbance of the longshore drift in the region. So there is definitely there is the impact of the post. Also the port, also the other environmental impact because of the port is there from the pollution point of view and other things. Coastal mining is another major issue nowadays. In the newspaper you might have seen that coastal mining is one of the issues, sand mining and other things. Because of the sand mining also it aggravates the coastal erosion. Coastal constructions, the ingress of the seawater, various places in the coastal zone is affected with the saltwater intrusion. Basically, the areas which are near to the coast and where there is extensive rise of the local sea level, or there are anthropogenic activities like because of the salt farming activities, where we do mine the groundwater near the coast. So there the probability of ingress of the seawater is maximum. And because of the ingress of the seawater, the underlying aquifer, the freshwater aquifer, will be replaced by the saline water. So the water which are used for the potable purpose or the agriculture purpose by hand pump other things, suddenly the water will be replaced by the saline water, which is of no use. Particularly in the Gujarat, we have done some study. I will show you that it has been seen that saline water intrusion has taken place even up to even 25 to 30 meters toward the land from the coastal area. Also there are impact of the power plant, because power plant also do put lot of effluent with having high temperature, the ash products in the coastal water. It has been seen and also picked up by satellite data. And definitely there are impact of tourism, because tourists are also create a lot of issues in the coastal zone by putting plastics and other material. They also destroy the corals, mangroves and other things. So those things also need to be taken care. So basically, now if we want to develop some coastal zone management activities, basically first and foremost, what we supposed to do, basically we need to collect lot of data concerning coastal zone. Whatever the data regarding coastal zone is there, we should collect all the data. And definitely, as we have told, the coastal zone is very dynamic, so data should be up to date. Particularly maintenance of this data, keep it up to date, because coastal zone, basically if you want to do study, we should rely more on the latest data. It is not like old geological or geomorphology map or geology map, which is not going to change very fast. But in contrast, coastal zone is changing very fast, so data should be up to date. We should rank the data reliability based on their scale, source, age and material. Monitoring the inventory studies. Inventory means how much material is there, like how much mangrove is there, how much corals is there, and how much is a mud flat. Those inventories should be made. This you can do very well using high resolution satellite data, and also definitely with some field component for the classification purpose. You have to, and then afterwards you can generate the thematic maps using various image processing techniques using satellite data. And those maps or those information of the coastal zone, definitely it will support the management of the planning activities by providing necessary and sufficient information on the coastal zone. That means if you're generating even a thematic map also, you are doing certain activities pertaining to the coastal zone management activity. So you are also contributing for the coastal zone activity. It is not possible for some person that he will do everything on the coastal zone management, as I have told earlier. Like generating a thematic map, right? Thematic map also is activity which adds to the coastal zone management. Also, you should support being a scientist. The for the policy writing concerning the coastal zone by the various policy makers. And definitely it is always needed to do research, particularly for the management and the planning problem in specific area. Some coastal zone is highly complex, so definitely like the example I giving you, like talking about the ocean color, particularly the it is very difficult to get information immediately of the ocean color with the we call the case to water, the coastal water, because coastal water, the optical properties is not only depending on the phytoplankton, there are so many other factors are responsible. So definitely you should do always some research to fine tune your algorithm, so that a robust algorithm can be come up which can give you immediately all the ocean color information from the case to water. Case on water definitely comparatively simpler. So the few the satellite data for example I would like to show you, like this is, you can see the image from along Kakinada coast in Andhra. It has shown that the red one is the your mangrove patches, the standard false color composite, so vegetation will come as red. So and you can see the mangrove degradation due to aquaculture along Kakinada coast. So all the aquaculture farms, you can see the black square area. They are the aquaculture farms, and unfortunately, the aquaculture farms has come up cutting the mangroves, and which is totally against the our coastal regulation zone regulation, because mangroves come under the CRZ1, which you cannot cut, you cannot destroy. But unfortunately, because aquaculture is highly profitable business, so people have cut the mangroves and set up the aquaculture farm. So that is why now our apex court, that is Supreme Court of India, has told that aquaculture practice is banned in this country. So, but whatever the aquaculture is being practiced, so many places in West Bengal and the southern part of our India, so they are still going on. But satellite data, you can see it's a geospatial technology. Like this is the image of IRS merged data of IRS 1C and the PAN. So 2.5 meter, 5.8 meter resolution. So I can find out, I can digitize all the aquaculture farms, and I can find out how much area is aquaculture in the year 2003. Now I can acquire data in 2020. Again I can find out how much aquaculture. I can find out the area. Then if the area is less, that means no aquaculture has new aquaculture has come up, things are under control. But if the area has increased, I can digitize new areas where aquaculture has come up using cutting the mangroves. So there is a concern. So definitely then we should take some steps to control the mangrove deforestation, setting up the aquaculture. But basically, as per the CRZ regulation rule, you cannot do any this type of activities, cutting mangrove in the coastal area. So this is the bigger satellite data. So this is, you can see the your Kakinada speed, and here this is the area I showed you in the earlier image. This is the Karinga mangrove, the red color, and here all the mangrove has been cut for the aquaculture farms, which is very unfortunate. So this is a Google Earth image. This is a ship breaking yard along the Alang. So you can see all the ships have come up for. This is not a port or harbor for the anchorage. They are there for to be broken, because they have the life is over as per the international maritime laws. So they have to be broken, and Alang is the Asia's biggest ship breaking yard, where they have come to break basically. And but unfortunately, the norms for breaking of a ship is not being followed. And along also there are a lot of problems with the child labor, lots of pollution. You can see the color of the even coastal water. So all the pollutants from the ships, particularly the iron and other metals, they are basically mixing in the water, and the water is going parallel to the coast further distance from the Alang, and is being degraded the water quality surrounding places also. And there are a lot of other sociological issue in Nalang ship breaking yard particularly. So this is also one of the area is maybe we earn money but there are a lot of concerns we should take care, particularly for the health and hygiene and environmental point of view in along coastal area. Now let us talk about a little bit of the scientific part of the remote sensing, how it can be used. Particularly, it can be also used to understand the bathymetry of in a coastal area, because the remote sensing consists of by now you are all you are aware of the various kinds of remote sensing band, like different wavelength. It starts from the blue, green, red, NIR, SWIR, thermal, infrared. There are lots of band basically. They are in a satellite data, and all the bands has different attenuation capability in the water. So you can see the red light attenuates rapidly in the water, doesn't penetrate deeper than 5 meters. So using red band, I cannot get any information more than 5 meters in water. Blue light penetrates up to 15 meters, and in the clear water it can go even up to 30 meters. The green light penetrates as far as 15 meters in the clear water around the coral reefs. The coral reefs, wherever there are the coral reefs, the water is very clear, very transparent. So the green light can give you information up to even 15 meters. But NIR penetrates to a maximum depth of 0.5 meter, and the IR is fully absorbed. So that is also one of the important aspect of the NIR band. Particularly, NIR band is very useful to give you the information with the land and water boundary, because the land part will be getting reflected, but in the water part it will be absorbed, and the water pixel, particularly water, if doesn't have much sediments, the pixel values will be not zero, but maybe varying in between 0 to 10. So it will be all the black color. So I can digitize pretty well the land and water boundary. Though if the water having more sediments, then the boundary will be a bit fuzzy. Then there are other algorithms are available to get a clear land and water boundary. There are a lot of publications. So NIR band also very important to the for getting the land and water boundary, and land water boundary is also very important for various aspects particularly. So you can see the remote sensing can also help you give information of the sub bottom topography. Also it will help for understanding the bathymetry. It will help you to update the bathymetry chart basically by Indian Navy. There is an office in Dehradun, we call the NHO, National Hydrographic Office, who prepares the bathymetry chart, but the charts are not being updated very regularly, except the areas which have international borders. So those areas which is not being updated, so those area you can use satellite remote sensing data. You can update those chart using remote sensing, and also nowadays microwave remote sensing data, the active remote sensing data people are using to understand the bathymetry. So I don't know how much this table is clear at your end, but I'll try to just tell you that what are the various parameters or the resources where remote sensing can be extensively used, and what are the present status. So like mapping of the mangroves, coral reefs, salt pans, agriculture. So they are mapping and monitoring in the different scale based on the special resolution of the remote sensing. They are operational using high resolution sensor from the Indian remote sensing. So it's a proven they are operational. You can operationally you can use those data set for mapping various kinds of coastal inventory, coastal resources. Fishery like forecasting and the monitoring. Semi-operational using NOAA VHR data and the IRSP4. IRSP4 we will use for the ocean color, will give you information of the phytoplanktons, and NOAA VHR for the temperature. So this is a semi-operational, as I told, because the algorithm for single algorithm for getting the chlorophyll for the case 1 and the case 2 water is different. So it's a semi-operational stage. Algorithm fine-tuning is going on so that it can be more robust. Coastal geomorphology and the shoreline changes, I can do its operational also for mapping and monitoring the different scales. We can gain information in the sea surface temperature using NOAA VHR data and the other sensor also, Indian sensors, which will give you one of the input for the potential fishing zone. We can get information of the wind, wave, water vapor content, which are being used for the fishery forecasting, monsoon study, ocean and atmospheric study. So they are also operational with IRSP4 and other foreign satellite. We can get information about the upwelling areas, the eddies, gyres. They are also very important to understand the potential areas of the fishing, because in the upwelling areas, the cold from the ocean bottom, the cold water with lot of nutrients, they are coming and mixing in the top warm water, which can be picked up by the SST map by NOAA VHR. Very nicely you can pick up the areas having eddies, gyres, upwelling. So those areas having more of chlorophyll, so the chances of getting fish are more in this region. Also it's a dynamical process, so it will help you to study the ocean dynamics, and you can use IRSP4 and the other data. Coastal regulation zone mapping, inter-Indian coast CRZ mapping has been done in 1:50,000 scale and 1:25,000 scale in different areas. based on their usefulness. They have been mapped using either 1C and 1D data. SSC mapping, suspended sediment concentration mapping, now is also again semi-operational IRS-P4. Quantitative analysis of the suspended sediment is possible. One of the major pollution effect in the coastal area, particularly the oil slick in the deep ocean and the coast, their mapping and monitoring is possible using microwave remote sensing data particularly. These are highly oil slick can be picked up very nicely using active sensor data. Chlorophyll concentration, as I told already, using IRS-P4 data. Also current and the surface circulation pattern can be picked up by various satellite data. Now when we talk about the few coastal hazards, basically it can be divided into two ways. We can talk about the short term hazards, like it will come and go with lot of havoc, like cyclone, hurricane, typhoon, tsunami, flash flood. And long term hazard is a chronic hazard like land subsidence in the coastal area, sea level rise, coastal erosion, those kinds of hazards. Cyclone basically it's an atmospheric closed circulation rotating counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. Along with cyclone, another two term basically we talk about the storm surge. Basically it's the abnormal rise in the sea level accompanying a cyclone, another intense storm, and also there is a storm tide. And hurricane and the cyclone basically we can see it's a basically tropical revolving system. They are called cyclone when they occur in the Indian Ocean. When they occur in the Pacific or the Atlantic Ocean, they are the typhoon or the tornado. It's a basically low pressure system depression where the air molecules circulates in a anti-clockwise direction in the northern hemisphere and clockwise in the southern hemisphere. And as per the IMD, the speed of the circulating air should exceed 33 meters per second near the Earth's surface. So when there is a tropical cyclone, basically it's associated with strong wind, storm surge of the local sea level rise, and also associated with the heavy rain. And strong wind basically create a lot of damage to the structure, and also there are a lot of destruction of the crops. Storm surge of the sea level rise, the water will come up and water will inundate the near the coastal area, so there will be a lot of flooding, and also flooding will cause lots of damage to the structures. Lot of damage to the structure will cause loss of life. Flooding will cause loss of life. Also heavy rain which cause flooding, and finally flooding will cause destruction of the crops. So in a single, like you can see on it, one tropical cyclone is causing a lot of havoc in the area, like damage to structure, the flooding, loss of life, destruction of the crops. See, this is the image, inside image, you see the how the eye is rotating and super cyclone in the Odisha coast in the year 1999. Now there is a landfall, it is now coming to the coastal area, so we can monitor very nicely the movement of the eye. And also nowadays various models are available, very high end model by IMD, and now people are tracking the cyclone eye along with the track forecast, the landfall time, how much water will go in inside the land. Everything is possible and is pretty accurate. So now devastation because of the cyclone is much less, particularly when infrastructure devastation is concerned. It is there, but human loss, so we have minimized quite a bit because of the high accurate prediction of the cyclone, and where satellite data is one of the major component which goes inside the model. When data assimilation people are doing, satellite data is one of the important component. And you can see the below some of the field photographs during those days of the super cyclone in the Odisha, and you can see the if I again start this image particularly, you can see the when it is landfall is happening in the Odisha coast, the prediction was that during those that it will go to West Bengal, and from West Bengal it will go to Bangladesh, but from 28 October to 30th October it remained in the Odisha coast only, the eye. So it only remained in the Odisha coast. That's why it create havoc, and it goes up to the final level, which is called the super cyclone of the cyclone scale. So that's why lots of destruction has been happened. Now, one of the major usefulness of the remote sensing immediately we can do of the cyclone, like to find out the health of the vegetation using an index called NDVI. NDVI basically is IR minus R, the infrared minus red by infrared plus red. So values range between -1 to +1. More the values towards the positive side, the vegetation health is okay, because in the IR domain the maximum IR will be reflected by the healthy vegetation and the IR will be absorbed. That's why the index is very popular. So you can see that in the Odisha coast, this is the Bhitarkanika mangrove. So the values, it has been multiplied by 10, so that's to get a whole number. So values are all 6, and all the other coastal values, you can see the green color values are 5. So other healthier vegetation. So this is the pre-cyclone NDVI. This is based on the WIPS data. It's 11th October 1999. But the same area after the cyclone, this is the data on 14 November data. And so you can see the NDVI values. So you can see the all the coastal vegetation having the green color, they have been replaced with NDVI values with 2 or even 3. And even you can see the entire mangrove patch, the Bhitarkanika mangrove patch, it from the pixel from the NDVI value 6 has been transferred to 5. Lots of, yeah, and there are lots of also other waterlogged areas, values are very close to 1 or negative side because of the waterlogging. So and all the other coastal vegetation, you can see the how the health has been degraded, which can be clearly depicted by the NDVI value of the pixels. So you can find out like this, that how much vegetation has been affected because of the cyclone in any region. And this type of study has been done recently by cyclone Amphan in the West Bengal coast. Also some publication I have seen. Also this the work has been done immediately after the by the Odisha Remote Sensing Application Center ORSEC in Bhubaneswar. And so this type of study is very useful to understand that effect of the cyclone on the agriculture area, on the mangrove patches, and immediately the relief and other, particularly the report can go to the government for the relief and the rehabilitation and other things, how it can be retrieved. So those type of study is very much useful for the pre and the post disaster study. So this is a image showing the CRZ mapping is a Panaji area in Goa. Particularly, you can see where the land low water line and the high water line has been demarcated, and CRZ boundary yellow line, that is basically a 500 meter buffer from the high water line towards the land. So this is the CRZ boundary. But this is a boundary only. Now also we can map the different CRZ like CRZ 1, 2, 3 and 4 using remote sensing satellite data. You can find out so like how much area is coming under the CRZ boundary. So what will be the prohibited and the permissible activities in that area. So there is a Government of India Rajpatra given by the Ministry of Environmental Forest showing that what are the permissible activity in the CRZ 3 or CRZ 4 or CRZ 1. So everything is written, and the entire India map has been done, CRZ mapping in 1:50,000, 1:25,000 scale. But afterwards, various other committees came up also to modify the CRZ concept, like Swaminathan committee, latest the Solis committees, and also because where they are incorporated the concept like coastal vulnerability. It is not that everywhere it has to be 500 meter. So based on the coastal vulnerability, we can do mapping like the areas which are not vulnerable at all. We can always go for some construction activity, some like some industry may come up, but the areas which are highly vulnerable, so those areas we should avoid. Basically, we can always generate some setback line to understand which area is vulnerable, which areas are non-vulnerable. But those vulnerability concept was not earlier that earlier CRZ concept, the first one. But afterwards, now there are other committees have come up, and things are improved also. GIS has a very strong role in coastal zone also, because coastal data are mainly the spatial data. It's a three-dimensional data, X, Y, and Z, and also the coast also basically we call that 4D GIS, because time is also very important. So GIS for our integrated coastal zone management makes sense for analysis of the larger and the richer database, quality control of the data, modeling. We can generate the various kinds of simulation of the coastal processes. Like if simulation means I'm talking about the, you can simulate a scenario, like if there is a sea level rise of 0.5 meter, 1 meter, 2 meter, how the neighboring coastal area is going to be inundated. Those kinds of scenario you can generate with a GIS environment, and accordingly the decision level planning can be done. Like scenario testing of the management options, I can generate different scenario, and as per the scenario we can definitely go for different kind of management options. Like decision support, including rapid response to disasters, like if suddenly there is a cyclone, then how the what are the areas they will be suitable for the cyclone shelter, from where we can reach to the distressed places. So all those highly important, particularly during disaster time, and GIS can be of great help in those areas. can see these are the what are the various kinds of layers that's supposed to go in a GIS, like ocean color, which may be a raster layer. So as you know, the GIS, there may be a raster data, there may be vector data. Ocean current will go as a vector data, bathymetry will go as gridded data. Like there may be a different point data, coordinate, station measurement, like temperature measurement, like measurement of the particularly some particular quality of the water, like pH measurement. They are all the various concentration measurements. So they are the point data, and there may be the sedimentary facies mapping, like seafloor meshing. So all those different layers, they will supposed to superimpose in a GIS and get some solution for this certain kind of study, which was not earlier possible to incorporate various types of data. Like you see, there's a point data, there is a vector data, there is a gridded data, there is a raster data, there is a sedimentary facies. So all can be joined together in a GIS. So it is a basically is a platform which is the ability to integrate data of different types from different sources. Okay, so which is very important for the coastal zone management. So and also it will enhance your capacity for exchanging of the data in various disciplines. GIS has the ability to process and analyze data more effectively and more efficiently, which may not be possible without this, because earlier people used to do using is a transparency and underlying there certain kind of lights used to be there, and we used to digitize the maps and superimpose one over the other, try to understand a scenario, but it was very cumbersome and difficult. Also, there are a lot of errors, but now things are very smooth and easy. Now there is a GIS has the ability to model, test, and compare different alternative scenarios. The updation of data is very easy. Simply we have to update data, data will be getting updated, and also ability to handle large volume of the data set of different format. So it's a basically, but coastal GIS has the different challenges, particularly as it works in the three spatial dimension. So the parameters changing both in X and Y, along with the when you go to the depth, particularly also the pressure is changing, temperature is changing, lot of parameters are also going change. So it has a three spatial dimensions you have to address. Working on the temporal data, because it's a very dynamic region, so time is also very important here. So that's why it's a major challenge. It's a dynamic process. The boundaries are very fuzzy, we have discussed several times, so very difficult to defining objects. Lack of coastal data models, definitely, because all the GIS software now available, they are basically based on the land processes. But really, to address the coastal area, you need a specific coastal data model, which is still lacking in the GIS industry. So basically, coastal GIS, that's why I used to tell, is not a very mature technology. There is no GIS software dedicatedly uh, invented for the coastal purpose particularly. So we used all those like ArcGIS, the ELUIS, other, they are basically the land-based application, but we're using for the GIS for the coastal purpose, because we don't have any other option left. Also, support from the commercial sector slow to emerge, but they are growing, and also coastal managers and the scientists are not yet a major lobbying group in the GIS industry. So that is another challenge for the coastal GIS. And also, when cost is concerned, there is the issue pertaining to the cost. Okay, all as data, it is very difficult, and also the sensitivity issue, security issue. Entire coastal zone is a classified area, so neither you can digitize any contour, or you can just without any permission you cannot gather the data which are like very secret data, coastal area. So there is a security and the sensitivity data. Also time series data, because the one kind of one data set, if you acquire, that will not serve your purpose. You need to go for a time series data to address what is happening in the current time, and if that data are available, are they in the suitable form. Now I think I have few more time. I'll just show you some of the selected coastal marine applications which has been done in IARS. But this is a basically erosion accretion along the Kakinada coast, where we can find out that Kakinada coast is particularly Kakinada Spit is eroded with time. So using multi-temporal satellite data or servo window topography, we try to understand where are the areas where, so like erosion is happening and where accretion is happening. See, like entire the spit has a one end will be attached with the mainland, another will be terminating in the open ocean. But you can see this part where the attached with the mainland is highly erosion prone. Now if that attachment is not there, then it will be no longer a spit, and spit is basically acting here, it is like a natural barrier to protect the Kakinada port. from the cyclone and other natural disasters at Bay of Bengal. So it's a natural protection. So if its speed is not there, definitely Kakinada sport future will be at stake. So definitely we should see how the speed can be protected. A lot of people have worked on the Kakinada speed, like along with ISRO, Survey of India, NHO, and so many other bodies, CWPRS at Pune. So they have also suggested certain protective structure. One breakwater has come over here to protect the erosion at these places. To protect the speed. So and multi-temporal satellite data can help you to understand how the speed is changing with time. This is soil line changes using multi-temporal satellite data in the Bhavnagar coastal area. So you can see images of 2003 where soil line has been shown on the red color, and 1970 which has been digitized from the Survey of India toposits. The soil line is the blue, and you can see the how the soil line has changed with time of around 33 years. So some part is getting eroded, some part new land is coming up. So there is a erosion is happening, deposition is happening, highly dynamic coastal area. So we can find out how the soil line is changing with time using multi-temporal satellite data. And definitely if you try to understand what is the reason, definitely we should go to the field, do extensive field work, try to understand some models. There are a lot of models nowadays available to find out what is the reason, how much sediment transport is happening, and why some places is erosion is happening, why some places the deposition is happening. So this is again some work we have been done for saltwater intrusion along the Gulf of Khambat. You can see this we have white color. They are the salt encrusted mud flat. So Gujarat is the state which produce maximum salt in our country. So they are the all salt pans, the square. So looks like very close to aquaculture. They are the not aquaculture. They are the all salt pans. So salt pan basically the areas is supposed to be along the creeks during high water time. The water comes and we're supposed to take the water, spread it over the field, and because of the scorching sun rays, the water will be gets evaporated, and there will be thin mineral of salt lying on the field, which may be collected, and very minor processing is required, and salt is ready. So salt farming is a, we call it low investment high yielding varieties, but we supposed to use the water during the natural water during the high tide time which is coming. But in Indian context it's a semi-diurnal tidal system, so there is a two high tide, two low tide in 24 hours. So if there's a morning 6 o'clock there is a high tide, evening 6 o'clock the next high tide. Now if you miss the bus, basically if you cannot collect the water morning 6 o'clock, you need to wait another 12 hours for to collect the water. So but we basically human being always we try to get some shortcut. So what people started doing over there, I have also a lot of field work done, and I have field photographs. People are started pumping the groundwater, local groundwater here in this region, which is also very saline, and taking those water for making the salt without understanding the hydrogeology. So more pumping is happening in the coastal water, more they are inviting the saline water to replace the fresh water in the aquifers, and the fresh water is being uh, pushed back towards the land, and almost entire area of the coastal area has been now covered with the saline water, which is not at all suitable for the drinking and the agriculture purpose. Now that is why, to find out whether really it is happening or not, we collected water samples from the various villages in their pump the talabs and the other means where they collect the water, and we analyzed in the Bhavnagar University from the chlorinated point of view. And also you may be aware that the standard of the WHO, World Health Organization, and the European Union, that in your potable water the chlorinated content should be less than 250 mg per liter. So if you drink water more than 250 mg per liter, in long run it will be hazardous for your health. So when we analyze that and make the contours of all the chlorinated contour values, it has been seen that you can see the only the green contour, which is around more than 30 kilometers from the land water boundary, uh, it is chlorinity of 250. Beyond this they are all less than 250. But green towards this side, toward the ocean, all are having chlorinated values 500, 750, and 1000. So all the villages like Alang, Sososia, Gandi, Goga, Kalatalabs, Gundala, so they are having all the villages, they are drinking water having chlorinity more than 1000 mg per liter, and this is very bad for health in the long run. And this is mainly happening because one way, naturally, because there is a sea level rise is happening locally, and there will be, because of the sea level rise, there is definitely there is a substitution of the saline water will go inside the coastal aquifer. This is there, but at the same time it is being aggravated by the salt making farms for mining of the saline water from the underground. So this is what is the situation. And we then we understand, we try to understand, if we try to model particularly to see what are the areas which are more vulnerable for saltwater intrusion, and what are the areas more less vulnerable for the saltwater intrusion. We try to collect the, because it's a mainly subsurface phenomena, though remote sensing doesn't have much role to play with. It's a more of a modeling kind of work, and with a lot of borehole information, particularly water quality parameters, well location data, like observation wells. We collected parameter like total depth, static water level, TDS, carbonate, bicarbonate, chloride, and the data is being collected from the Gujarat Water Resources Development Corporation, GWRDC, in Gandhinagar. And we collected data from the year 1983 2003, every 5 years interval, pre-monsoon and the post-monsoon season, May and October, because this type of study requires a different seasonal approach, because after the shower the scenario will be changing when groundwater recharge is concerned. So we need to understand what are the scenario pre-monsoon and what is the scenario has changed in the post-monsoon. And you can see the location, all the locations of the well locations have been shown in the Bhavnagar districts. Is pretty well distributed, and collected those data. Then using the model, we tried got some map of the vulnerability ranking around Bhamnagar city. In this is at 2003. You can see the red area. This side is the ocean. This is the Bhavnagar area. This all red is the highly vulnerable. Then this is the less vulnerable. This color is the moderately vulnerable, and the black one is the all the green one is the non-vulnerable region. But this is the May 2003. This is the pre-monsoon, and on the post-monsoon there are a lot of rain showers, fresh water goes inside. Then the scenario is changing. You see the highly vulnerable region is only restricted over here. Majority of the region is a moderately vulnerable. Also there is a lot of increase in the less vulnerable region. Also there are more patches that come up which are non-vulnerable regions. So this type of study can be carried out to understand what are the regions which are less vulnerable, what are the regions which are highly vulnerable for saltwater intrusion. And also from the socio-economic point of view, like all the villages, you can see it has been plotted, all the villages affected by chlorine of the groundwater more than 250 mg per liter, post-monsoon scenario, and the right hand side is the pre-monsoon scenario. And here you see the color, different color represent mg per liter, the chlorinity content, 250 mg to 500, 500 to 1000, 1000 to 1500, and greater than 2000. This is the, and less than 250 mg per liter we have not considered, because they are the safe region. So this is the all the villages which are being covered by certain kind of effect of the chlorinity content of the groundwater, and all the village, the location, and also we use to know their population. So we can find it out how much population is affected with the high chlorinity of the drinking water, high chlorinity concentration, pre-monsoon season and the post-monsoon time. These are some study for the to understand the storm surge risk zonation in the Odisha coast, to find out the what are the high risk zones. So areas which are very close to the, they have the Paradip, close to the coast, definitely they are the high risk zone, then the medium risk zone, and they are the low risk zone. And basically then we try to find out if there is a cyclone or storm surge, there is certain sea level rise, then what are the areas which are good for the cyclone shelter. So the region which will not be inundated, so people can can be evacuated and put on those places like high altitude hospital or the schools building and other places. So these are the all areas suitable for the cyclone shelter. So we find it out those region which can be acted as a cyclone center in the Odisha coast. So this what we were talking about, the potential fishing zone study, particularly this is a thermal image showing the font. So these are the all thermal font. You can see the eddies forms. So they are indicating the probable fishing zone, particularly because these have been formed by where from the bottom, the cold water with lot of nutrients they are coming uh, from the bottom circulation, and they are mixing in the top warm water and they form this type of structures, and the water which is coming from the bottom is coming with a lot of nutrients. So but definitely if the nutrients, they are the nutrient rich zone, and you can find out with the there will be a thermal gradient, because there is a mixing of hot water and the cold water. Along with that, there is also lot of differences of the chlorophyll concentration in the surrounding places. So these are the area chances of getting fish are more, particularly when NRS said that was the National Remote Sensing Agency were doing the PFZ map, when we didn't have the quantitative estimation to understand the chlorophyll concentration. All the PFZ maps were being generated mainly by the input from the sea surface temperature, like this. So now when we started getting the chlorophyll, then scenario has been changed. More detailed or more accurate PFZ map generation would have been possible. Like you see, this is in the Bay of Bengal area. SST derived from Noe data, 23rd April. And you can see already is a circulate form, like eddies have generated over here. In the same day, we tried to get the chlorophyll concentration from the OCM. See the 23rd April 2001. These are the OCM, and as we have already discussed, the chlorophyll concentration decreases as we go away from the coast toward the open ocean. The coastal water concentration is high. So this is the phytoplankton concentration, is mg per cubic meter. So you can see this. Then we superimpose in a GIS this both the map, and then we find out the different potential fishing zone on the same date, 23rd April 2001. High PFZ zone, medium. This is the almost, you can see the PFZ zone coincide with the eddies, which we got from the thermal image, SST image. So this is the high PFZ zone, when medium PFZ zone, low PFZ zone. This kind of demarcation was possible in earlier days, and nowadays the PFZ map has been increased, because now the technology has been transferred to NQuest at Hyderabad. So they operationally they produce the PFZ maps and distribute to all the fish landing center. All the fishermen now go with the GPS and the PFZ maps to catch the fish, and the fish catch has been increased tremendously, which is saving their human labor, the diesel of the trawler, and also the profit has been increased using the geospatial technology. This is one of the most successful project on societal development, particularly the fishermen's using geospatial technology. Also, the remote sensing has been used for various kinds of study. Like this is one of the study people have done in the latest tsunami. You all understand the tsunami, particularly it is a, like we call it, a subsurface earthquake, where from the there is a sudden displacement of the seafloor because of the seismic activity. The wave travels in all direction from the source area with speed over more than 500 km per hour, and when it is coming near the coast, the velocity reduced by 50 kilometer, and the height will be around 30 meter in the coast. And when from the deep ocean the waves are coming near the coast, mainly three things is happening. The waves will become compressed because of the less depth bathymetry is reducing near the coastal area. The wavelength will be compressed, the wavelength will be less, wave height will be increased, and at the same time the velocity will be reduced, but the energy will be the same. So because energy will be constant, so much of energy the waves will coming with lot of wave height. So and it will be breaking near the coastal area, a lot of energy, so there will be huge destruction near the coast only. But the open ocean, people will not feel there is tsunami. If there is a like ship or a helicopter is moving over the ocean, they will not understand the tsunami waves is propagating in the deep ocean. So that's why it is always advisable that if you are in the deep ocean, be there, don't try to come near the coast at the time of tsunamis, because coastal area is mainly affected. So they are the certain image, the pre and the post tsunami image in Indonesia. So the top one is the pre-tsunami, everything is fine, all the land parcels, agricultural land, nice Bande region, all the human habitation, everything is killed. And the next image is post tsunami, everything has been destroyed. So this is a satellite data. Because tsunami was on 26 December 2004. In the right one image, you can see this is the 27th December. The left side is list for multispectral data, 12 January pre-tsunami along the Marina Beach. And you can see the after one day of the tsunami, almost entire Marina Beach there is a water logging. New creeks have come up here. It was not there earlier. And also you can see there is a temple. That entire temple has been devastated by the tsunamis. So satellite remote sensing data is also very helpful to find out the inundation due to tsunami. What are the areas which will be inundated? penetration of the water body because of the tsunami towards the land can be easily traced from suitable remote sensing data. How much water has been penetrated towards the land, the runoff height, the inundation limit can be find out from the remote sensing data. Um, the inundation line, that means how much water has gone inside the areas which have been inundated, from that can be derived from the ground survey, can be superimposed over the taluk or the villageable map using GIS to have an idea about the affected agriculture area, human population and the agriculture. And so this type of map has been generated. This is a map generated by those days Department of Ocean Development by ICMAM PD in Chennai. So you can see here the tsunami inundation map. So here this blue line, so all the blue hatch, they are the inundation region. So they are the all village boundary, the taluks level, and the different observation point, the time, the also the coastal land use, land cover, the mud flat, the dunes, the tsunami inundation region, everything is there. So now we can find out that entire area or villages under the hatch line, they are the under the water. So immediately relief and rehabilitation has to be put in this region. So these are the beautiful map to understand how geospatial technology can help during the time of disaster, whether it is a tsunami or earthquake or cyclone, anything. So the extent of inundation of the seawater deep, you can see also the extent of inundation is not same in all the places. Somewhere it has gone deep, here it has gone very deep along the river or the nala or the creeks. The extent of inundation seawater depends on the earthquake parameters. More the severe the earthquake, more definitely will be the tsunami devastation. Nearshore bathymetry controls a very important parameter. Beach profiling, land topography, velocity of the tsunami waves, their frequency, and due to these all parameter varies in the different places. Due to these parametric variations, the inundation varies from one location to the other. So yeah, inundation will not cannot be a constant in any coastal region because it also depends on a lot of, if there is a huge mangrove patch, it will restrict the movement of the water towards the land. Or if there is a huge sandy dune, so it will also restrict the movement. So it depends on if there is a very flat mud flat, so it will go, water will go deep, much deep inside. So there are a lot of parameters, geomorphological parameters, land use, land cover, nearshore bathymetry, and also the coastal DEM. They have a major role to play with for this. So thank you very much for your attention.